This is CPM Calculus Chapter 2, number 121. So we have found or approximated the volume of a rotated flag of various shapes, right? We rotate it around the y-axis or whatever, and we calculate the volume. What is the axis of rotation? Usually it's the pole, right? Well, what if the axis of rotation is not attached directly to the flag? Okay. In the graph at the right, there's a gap between the flag and the x-axis, right? Here's the x-axis here, and there's a gap right here, okay? And here's our flag. Decide what will occur when the flag is rotated about the x-axis. Okay, so it's going to be rotated around the x-axis, okay? Okay, so when it's rotated around the x-axis, okay, it's going to look like something like this, right? So it's going to be a cylinder, right? We had a cylinder, but now in the middle, so we have a cylinder, but now we have a small cylinder hole. So we have a cylinder with a smaller cylinder like inside as a hole, right? There's a hole in our cylinder, so it's kind of like a big thick tube, right? You could think of it as I don't know, piping or something with a thickness, but in the middle it's hollow, okay? So a cylinder with a small cylinder inside as a hole, or you could say like a pipe with thickness, right? The thickness because it's 1 unit thick all the way around. Okay, so here's a sketch and find the volume of the resulting solid. Okay, so how do we do this? Well, you could think of this, we know that if, for example, this went, if it touched the x-axis, right, and we looked at the whole thing, then we would have just a solid cylinder. So we know like the whole cylinder, the volume of a cylinder we know is the area times the length. So the area of one side times the height of the cylinder, right? If we have a cylinder like this, we know that the volume is equal to the area on top, well, it's a circle, pi r squared, times the length or the height, right? So the volume of the whole thing is going to be pi r squared h, which is pi r. Well, if we're looking at the whole thing, the radius then going around is 2 units, 2 squared, and the height is from 1, 2, 3, 4, so that's 1, 2, 3 units. So that's pi times 4 times 3, or 12 pi units cubed, right? Because volume is cubed. Okay, so that's the whole thing. So how do we find just this section? Well, if we look at now just the inner open one, right? If we take the whole thing and subtract out that inner hollow cylinder, then we get the volume of just the outer cylinder, right? If we just take away the air inside, then we get the volume of our pipe, okay? So the inside, so the volume of the air inside, we know is another cylinder, so it's pi r squared h, but now our radius is just from 0 to 1, so our radius is just 1, and our height is still going from 1 to 4, so it's still 3. So our volume of the inside is going to be, well, 1 squared is 1, times 3 is just 3 pi units cubed. So our cylinder, right, our cylinder is equal to the volume of all minus the volume of just the air inside, which is 12 pi units cubed minus 3 pi units cubed, which is, so we combine like terms, is 9 pi units cubed. Okay, so this is the volume of our flag if we were to create a cylinder with it when it's not going to, when there's an empty space in between. Okay, so this is CPM Calculus Chapter 2, number 121.